Today we're going to look at section 3.5. This is going to have us use overlapping triangles in proofs. So I would like you to pause the video and ask yourselves, how many triangles do you see in each of these figures? All right, so hopefully you took a moment to kind of look. In the first one, we should have 1, 2, 3, 4, 5, 6. Here, let me kind of see if I can highlight them for you. So like here, that if I was to like color that in, all of this, there's one triangle. Okay. Then on the other side, there's a second triangle. Here, just this one, that's a third one. Here is a fourth one. This would be a fifth one. Put these two down here at the bottom. There's number 6. Put these two together at the bottom. That's number 7. And then you've got the whole big triangle. So that is 8. So in this first one, we should have said that there are 8 triangles. In the next one, we should notice that there are, and I'll show you with my highlights. So there's one triangle here. There's a second triangle, a third triangle, a fourth triangle, a fifth triangle, and then the big one is the sixth one. So there are 6 triangles in this one. So quite a few triangles. And so when we see pictures with a whole bunch of triangles, sometimes they will be overlapping. And so it's going to be super important that we are truly drawing our picture and then visualizing and marking up our picture to help us out with these proofs. So when we have to do a proof with overlapping triangles, it's important to know which triangles to look at. We're going to look over the given information carefully to see what triangles will be used. We suggest that you either highlight or redraw them when you are doing the problems so you can then see it clearly. All right, so I would suggest that you pause the video to go ahead and sketch the picture. Hopefully you notice that there are quite a few triangles. I see 1, 2, 3, 4. There's 5 triangles in this picture. All right, but we are going to be proving that angle D is congruent to angle C. All right. Since those two angles are actually made up of several triangles, writing down the given information and marking it up in our picture will hopefully help us see which triangles it is that we want to focus on. So one of my givens is that the segment AC is congruent to the segment BD. So if I look, AC is this big segment right here. BD is this big segment right here. All right, so those two are congruent. I can't expand off of that any further, so I'm going to move on to my next given. I am told that the segment AD is congruent to the segment BC. And then I'm going to mark that in my picture. So AD and BC. So if I start highlighting the triangles that are marked up, well, AD was the side that was marked up, so is BD. Hopefully we're okay with noticing that then, hey, put it with that side, and this is the triangle that we probably want to focus on because it also has the angle D that I need for my conclusion. If I look at the second piece, the second triangle, I see that BC was this side. We said AC was this side. Those two are sides that were marked up because of our givens. Well, notice that you can make a triangle with that side. So there's our 3 sides. Notice that the angle C that we want to prove to be congruent to angle D is within that triangle. So the triangles that we want to try to prove is that ADB is congruent to angle BCA. But right now, they only have 2 things that are marked. So we need a third thing before I can state that I have congruent triangles. Well, if you look at how I have the highlighted triangles, I see that these two triangles actually share a side. Both of the triangles at the bottom are highlighted with the side of AB. So I'm going to say that the side AB is congruent, but now this is where I have to be careful. I'm not going to write AB again. I have to write BA. And the reason for that is because notice that in the first given, A was first and B was second. In the second, same idea. A was first, B was second. So that means wherever I have an A in the first segment, I need a B in the second. So since I put A first, I needed B to go first. All right, so AB is congruent to BA. And remember, something is congruent to itself by the reflexive property. So then I can mark that in my picture. And now I do have 3 sets of markings. So like we said, those triangles that are highlighted would be the triangle of ADB, and that's going to be congruent to the triangle of BCA. And if you look at our markings, it looks like these triangles are congruent because of side, side, side. And notice that going back through my proof, the first 3 steps were of all congruent segments that happen to be in the triangles that we just highlighted. And now that I have congruent triangles, any other pieces of those triangles are congruent. So we are able to go to our 5th and final step, that angle D is congruent to angle C. And remember, the reason for this would be CPCTC. Corresponding parts of congruent triangles are congruent. All right. Let's take a look at another one. I'm given that the segment AC is congruent to the segment AB. I'm told that the segment AE is congruent to the segment AD. We want to try to prove that the segment CE and the segment BD are congruent. So I'm going to go ahead and I'm going to write down my first given that the segment AC is congruent to the segment AB. And I can mark that in my picture. So here's segment AC. Here's segment AB. So those 2 sides are congruent. I can't expand on that any further. So I get to move on to my only other given that the segment AE is congruent to the segment of AD. So AE is congruent to AD. All right. We want to try to prove that the segment CE and the segment BD are congruent. So let's see. For whatever reason, it's not letting me highlight. Okay. All right, so let's see if I can highlight now. So if I want to try to prove that this side CE is congruent to BD, which let me highlight that with a different color, we have to think about, well, what triangles are going to be a part of those 2 sides, but also probably have something to do with the pieces that we already have congruent. Notice that I already have AD and AB marked up in my picture. So notice that that goes nicely with the segment BD that I'm trying to prove with that triangle up there at the top. And then same idea, if I want to try to prove CE, but notice that I'm already given AC and AE. All right, so those are the 2 triangles that we're going to want to focus on. I already have 2 sides of the triangles, and because in the very end I want to prove segments, what did I say? I already have 2 segments marked congruent in the triangles. I want to try to prove the 3rd segment. So we're not going to be getting congruent triangles by side, side, side. So that's nice to know. We're looking for an angle. So I want to know what is an angle that we can see is congruent with both those triangles. And I know it's not something that we've been used to much, but in this case, there actually is an angle where those two triangles are overlapping. That's up here at the vertex of A. If you notice that my highlights, I mean, the yellow kind has overtaken the green, but they're both highlighted at the top with angle A. And there is only one angle A. So my third step, I can say that angle A is congruent to angle A, and this is because of the reflexive property. So a lot of the times we've always used reflexive property with segments that overlapped, but now here we have an angle that the two triangles share in common. So now that I have that, I've got three things. Here, let me mark that. I have three things in my two triangles, and so I have enough information to prove that those two triangles are congruent. So let's say triangle ACE is congruent to the triangle of BD. Okay, so notice that the A's have to go in the same spot. C and B have to go in the same spot because of my first segments that were given congruent. And then notice that E and D have to go in the same spot because of the second set of segments that are congruent. All right, so if I'm looking at how are these two triangles congruent, if you focus on here, let me like redraw this one triangle. Notice how if I'm looking at the triangle of ACE, well, angle A is marked, the side AC is marked, and this side, AE was marked, and the side of AC was. So if you look at my sketch, it looks like it's because of side, angle, side. The angle was in between the two sides. So notice that my first step got me my first set of congruent sides. It was step number 3 that got us our congruent angles. Step number 2 takes us back to a set of congruent sides. And now that I have that, any other pieces of those triangles are congruent. So CE is congruent to BD. And hopefully we're okay with, once again, this is because of CPCTC. Corresponding parts of congruent triangles are congruent. All right, let's look at another one. So once again, please pause the video, sketch the picture. We're going to be marking up the picture. All right, so I'm going to write down my first given that the segment FH is congruent to the segment MJ because that's given to us. And I'm going to mark it in my picture. So FH is this whole piece right here. MJ is this whole piece right here. I can't expand on that any further, so I'm going to move on to my next given. I'm told that the segment FG is congruent to the segment MK because that is given. Well, FG is up here, MK is up here, so I'm marking them the same. I can't expand on that any further, so I'm going to move on to my third and final given that the angle GHJ is congruent to the angle KJH because it is given. So GHJ is this angle. KJH is this angle. So while there are overlapping triangles in here, because there are quite a few triangles, there are actually some shapes that are not triangles as well. So that might help us visualize things a little bit better. But notice that because of the angles that I just marked that were given, and notice that what I want to try to prove congruent is the segment GJ, which is this segment right here. Notice that the angle of GHJ would mean that, hey, maybe we should focus on this triangle. And then because I want to try to prove that the segment is HK, well, notice that angle KJH is probably going to be a part of that one. All right, so those are the two triangles that I want to focus on. And if you look at what's marked up, only the angles are actually a part of the triangles we're trying to prove, to be congruent. Okay, so then what was the point of us giving you the first two pieces of information? Notice that FH is a really big segment, and notice that FG is a small segment above the side that's a part of our triangle. Well, hopefully you notice that GH, so this segment right here, if you put that together with FG, you get the big segment that we know to be congruent. If I take MK and KJ and put those together, I get the big segment that I already know is congruent. So here, I'm technically starting with something big, and I can prove something small. And so to go from something big to something small means subtraction. So let's make our fourth step be that the segment GH is congruent to the segments KJ by the subtraction property. So once again, I'm going to show what it is that I'm subtracting. I started with the big segment of FH. I'm subtracting that top piece away of FG, and that's going to get me then the segment GH. I start with the big segment of MJ. I take away the small piece on the top, which is MK, and that leaves me then with the segment of KJ. So I can go ahead and I can then mark those two sides congruent. And now I have two pieces that are marked in those triangles. I got to find a third piece. Well, hopefully you noticed that when we were highlighting these triangles, they did overlap at a similar segment. They overlapped at that bottom segment of HJ. So I'm going to say that the segment HJ is congruent to itself. And so because I started with H first, I have to start with J first in the second part. Because once again, if I'm looking at the fact that H is second in the first segment in the first given, and J is second in the first given. And then notice that like H and J for my angles in step 3 are in the same spot. So I know wherever there's an H, I wanted J to be in the same spot. So that's congruent to itself by the reflexive property. And then I can mark that. And now I do have 3 things that are marked in my picture, so I can name those triangles. So it's the triangle of GHJ congruent to the triangle of KJH. And if you look at the markings, it's because of side, angle, side. So my first set of congruent sides that are a part of the triangle were not step 1 and not step 2. Remember, both of those given pieces of information or not sides of the triangles I was trying to prove congruent. It took until step number 4 where we had to subtract them. That's where our first set of congruent sides for the triangles were. My congruent angles came from step number 3. And then step number 5 with the reflexive property got me the other set of segments to be congruent. And now that I have congruent triangles, I can prove that any other pieces are congruent. So the segment of GJ is congruent to the segment of HK. And this is because of CPCTC. Corresponding parts of congruent triangles are congruent. So that's us using overlapping triangles in proofs. So once again, highlight them or even draw them separately. That's going to help you out.